What was the question? ये क्या हो गया भाई? Black screen. Huh. I guess it's working now. And okay. In order successor in BST. In order successor in BST. In order successor in a binary search tree. Okay, you have been given a binary search tree and you need to find the in order successor. Okay. Okay, let's see, you have been given some binary search tree. You need to find the in order successor to the pth node. Okay. In order successor to the pth node. How will I do it? If you think 5. If I have a node like this and p given is 6, p is 6, right? That means, okay, to any node in a binary search tree, the node that is greater than it is at its right or its parent. So if I'm standing at p, that means that I have to go right or to its parent. To go right or to its parent if I stand at p. If I don't stand at p, then I have to keep going right until I find p. Okay, wait. Okay, p is what? P is 6 node. So p will obviously be there. So I start here. If current node is less than p, I move to the right of the tree. Current node dot right. DFS of current node dot right. I moved right. Okay, it's moved right. Otherwise I move. Otherwise what? If less than p. If it equal to p. If current node is equal to p. Huh. It can be less than p or it can be even. If current node is greater than p, can it be greater than p? Maybe it can be. I guess, right. If current node becomes equal to p, and if cn dot right is not equal to null, then this is the answer. If current node is p and its right is null, then current node's parent node is the answer. No, for 6 in order successor is none. Okay, for let's say 4, right? What is the in order successor? It's 5. It's the parent node of p. Parent node of p. If this is p, इसका parent is 3 and then that guy's parent is 5. इसका parent 3 है और उसका parent 5 है. That's why that is the answer. This guy doesn't have a right child. Okay, its parent is the answer. Okay, I can't understand it. If the current node p, okay, if root dot val is less than p, we simply move to the right. Current node is 5, p is 4. If current node is less than or equal to p, cn is not less than or equal to p, cn is actually greater than p, so you move what else? T node left will be equal to successor dot. Okay, so we know that the current node is itself greater than p, so current node might be one of the answers. I don't know. T node left is equal to successor of root dot left and p. Left will be equal to, you call DFS on the root dot left. 5 का लेफ्ट 3 पे DFS कॉल किया and then this DFS 3, is it greater? No, it is lesser than. Return successor, you return 3 dot right. Okay, return DFS of 3 का right 4 है, and then 4, if root dot value is equal to also, you go right. So this guy will return none, null, and this 3 guy left is equal to DFS, left is none, null. So P's left is what you got. Left is null. So if the current node is greater than P, means that you're standing at a parent of the parent of P. Basically we want to find P's closest node in order traversal, and the node's value is greater than P's value. Right, yes, that node can be either be P's parent or the smallest node in P's right branch, correct? P's parent. But P's parent here तो छोटा है यार. P's parent here is what? If P is parent node, there are two. P doesn't have a right child. In that case, the recursion will eventually return null. So P's parent is the successor. Number 2, P has a right child. Runs into that, means that current node is either P's parent or node in P's right branch. It's P's right child. If P's parent node, there are two scenarios. P doesn't have a right child. In that case, the recursion will eventually return null. So P's parent is the successor. The recursion will eventually return null. P's parent node, if it's P's parent node. When the code runs into else block, means that the current root is either P's parent or node in P's right branch. Okay, current root is greater than or equal to P. Greater than. Okay, current node is greater than or equal to P. Then else means root dot val is less than P. Code runs into else block, it means current root is either P's parent or a node in P's right branch. Current node is P's parent. Root dot val is whoa, ulta, I'm seeing the wrong code, man. Okay, if root value is less than or equal to P, you return the successor of root dot right. Just keep going right until you find the proper node. Okay, let's say if there was a 7 and 8 here, who is the successor of 6? In order successor is 7, right? So P is 6. Then if P has a left child, how is he covering this, dude? If root dot val is less than P dot val, yes, return successor of. So we call successor of 6. If root dot val is less than P dot val, successor of right. Okay, it will go to 7. It will go to 8, not 7. In order successor of 6 is not 7. Okay, then it will go into else part. Okay, tree node left is equal to successor of root dot left. 8 is greater than 6. So valid binary search tree. It is valid binary search tree. 5's right is 6, 6 left is 7, so 8. क्या फालतू क्वेश्चन है. Okay, return left will be successor of root dot left. 8 का left है. Wait. Current node is 5. 5 is less than 6. So you move right. okay, and then s of 6 is called, and then you see again root dot val 6 node is also equal to 6 node. You move right again, so s of 8 is called 1 2 3 4 5 6 7 8. सब कुछ 5 के राइट में 6 7 8 ग्रेटर 6 के राइट में 8 7 6 is, अरे यार, this is not a true binary search tree. 7 is not there. Okay, in the binary search tree for any given node, in the binary search tree for any given node p, it will be either the right child or its parent. Okay, or its parent. For 4, for example, it will be 3 was the left child of the root, and it will be 4.
Saying goodbye.
क्या फालतू क्वेश्चन है यार ये. सो पी का पेरेंट का, सो पी का पेरेंट का पेरेंट, okay, you call s of 8. When you call s of 8, right, root dot val is left, it will call.
ये तरफ तो नहीं आएगा भैया.
6 का right child is 8. 8 can have a right child 7, right?
हाँ बेटा, ये तरफ नहीं आएगा, ये मेरी तरफ आएगा.
7. क्या बेकार क्वेश्चन है यार. तो recursive solution is trash. Finding the first node in whose value is larger than the given integer value. It seems it cannot deal with tree with duplicate values p on one side. क्या बेकार solution दिखा है यार इसने तो. I've wrote okay, else, okay, if you are at a root, right, you are either at p's right, okay, if I am at 5, right, 5 is already, or you are at p's parent. That node can either be p's parent or the smallest node, p's right branch. Current root is more than p's parent. To find the successor, you just need to find the smallest one larger than the given value. Since there are no duplicate value, it is just a binary search. In a sorted list, the time complexity will be O of h. H is the depth of the tree node. Suck is the success. Keep the possible successor. Whenever you go left, the current root is the new possible successor. Otherwise, it remains the same. Yeah, that is a trash solution. This is a better solution, I guess. Okay, you have suck null while root is not equal to null. If p dot val is less than root dot val, you go left. Suck is root and y is successor root, because whenever you go left, okay, you go left and it doesn't have a right child, then you are stuck, right? That means successor can be root and you simply move left. If p is less, if p is equal also, you have to move right. That's all. Root will be equal to root dot right. Okay. root is equal to root dot right. इतना ही है. Wait. How will this solve 8 का? Okay, suck is null. Okay, root is not equal to null. Root is 5. P is 6. Okay, if p dot val 6 is less than root dot val, no. So you move root is equal to root dot right. Root goes to root goes to 6. Now they are equal. Also again you try to move right. Root is equal to 8. Okay, just keep moving right. That's all. Okay, if you find a value, okay, let's say for 4, how does it work? So okay, and p is equal to 4. The current root is 5. P is less than root dot values, so you have to move left and keep track of successor. Put it 4, and root will become 3. Now 3 is p dot val is less than root dot val. 4 is less than 3. Nope. So you need to move right. Root is equal to root dot right. Root is equal to root dot right. You got 4. Suck was keeping track of what? Suck was keeping track of p dot value was less than. Suck is null. P is 4. Root is 5. Okay, P is less than root dot val. Suck is root. Suck is root. Suck is keeping track of 5. Root is equal to root dot right. So root dot right. P dot val, which is 4, was less than 5. Yes. Okay, you move root to root dot left. Root to 5 dot left is you move to 3. Then you again compare. Is p dot val 4 less than root dot val? No. So you have to move right. Current node simply 3 dot right. 4 is 4 less than 4? No. So you have to move right again. Okay, so you move right again, and then you end up at null, and this thing finishes, and a successor will be equal to 5. Okay, whenever you move left, you only need to keep track of the root node, as the successor might not have okay, or you simply need to keep moving right. That's all. Okay, 4 के बाद क्या आता है? Okay, and 5. I have to move left. This is the value that I'm trying to find. And I move right, and then I move right once more. Okay, let's say there was a 4, 5. So this was 6, and there was a 5 here. Okay, and the right subtree doesn't exist. So we have successor is null. Current node is 6. Is 4 less than 6? Yes. So you need to track 6 in here and move this one current node to 6 dot left, which is 3. Is 4 less than 3? No. You simply move the current root to the right. If there was a 4, if this was 8, 4, 5, here you would have 6. Okay, successor successor is none, current node is 8, p is 4, p is less than current node, yes, so you move, you put the current node in the successor 8 and then you move right or move left. Current node will be equal to 3. Is p less than 3? No, so you simply move to the right. 4. Oh, you only move right when the current value is more or equal. Current node is equal to 4. Oh, this is not even a binary search tree तो है. Current is equal to 4. Then is p dot value less than? No, so you simply move right. Current will move to 5. Is p dot value less than root dot value? No. Yeah, what? None. 3, 2, 1, 4, 5, 6. Current node is 8. So 4 is less than 8. So we need to move left and save 8 and then move left. 3 is less than 8. No, so I move right. 4 is less than 4. No, so I move right. 5 is less than 4. Oh wait, 4 p dot val is less than root dot val. Yeah. Okay, p dot val is less than root dot val. 4 is less than 5. Yes. Successor is save root, and you have to move left. Oh, save 5 and then you move left. Successor 5 you save left and move left. Okay, makes sense. This solution makes sense. Okay, you just need to searching in a sorted list. Keep going right, keep going left, it will end up at null. Let's say if you had 4, 7 and 5. 4, 7 and 5. It will find this one also. P is equal to 4. Successor is null. Current node is 4. P is 4. Is 4 less than 4? No. So we keep moving right. Current node को 7 बनाया. Is 7. Is 4 less than 7? Yes. You have to save 7th node and the successor node and then move right. And then move left. Sorry. You have to move left. Current node becomes 5. Is 4 less than 5? Yes. You have to save 5 inside the successor node each time. Makes sense. Smallest node in the right subtree is the answer. Smallest node in the right subtree, or if there is no, then you have to go parent and then find the answer. What is such a tricky question here? Okay. Suck is equal to none. Current is equal to root, while everything not equal to none, while root to be comparison, while current, if current is equal to if current dot val, if p dot val is less than current dot val, I have to move left. Save this node. Suck is equal to cur is equal to What? Left. Also simply move right. Even if it's equal, you have to move right. Okay. If P node has a right subtree, successor will be smallest node in the P's right subtree. If it doesn't have a right subtree, the last node whose left subtree it is under. I record its right parent. Perfect. Okay, if I tell you to find the predecessor, it will be the largest node in the left subtree. Okay, I just need to move where to. I need to move if the current node P is less than the current node, then P is greater than the current node, in order predecessor है क्या? In order predecessor and successor, okay. If node is right, null, then return null. Its left subtree is not null. If key is found, then will be the rightmost child of left subtree, or the left child itself. If key is found, its left subtree is not null. Predecessor is rightmost child in the left subtree. Yes. If its right subtree is not null, then its successor will be leftmost child of the right subtree or right child itself. Yes, that is the.
Yes, you can do.
If you can't find the key, if the key is smaller than root node, set the successor as root. Oh, successor and search recursively into the subtree, else set the predecessor as root. Search recursively in the right subtree. This is a hard question, man, actually. क्या करें यार? Okay, let's say if you have 5 and you have a 4 and 4 successor you're trying to find, right? If P is less than current node, then you have to save the root node, bro. Let's say even if it was 8 and 4 and a 5, you will save what? You will save 8, man, because it needs to be the parent, the greater one. Where you are going left, where are you going left, you have to save that. Where I'm going left, I have to save that. And when I'm trying to find a predecessor, you have to save where you are going right. In the predecessor, okay, if P is greater than the current node, no, yeah, you're going right, but then you have to save the root node. 7. Right. If your P is 8, P is 8, then predecessor is 5, so you save the root node and then go right. Makes sense. In order successor, if root is equal to null, return null. While root dot val is not equal to p dot val. Okay, if you find p, then you can do anything, right? If you find p, one is the parent one, save the successor, or other one is you have to go right subtree. Successor will always be in the right leftmost child of the right subtree. Get leftmost. Last node whose left subtree. Yep. You save pre. Else if p is greater than root dot val, you simply go right. If p is less than value root dot val, p is equal to root, you have to go left and then you save the root and then you go left. Else if p dot value is greater than root dot val, p dot value you simply go right. Okay, it will end up at p dot p. And one, okay, right is not null, then the root leftmost. Makes sense. This is the best solution actually. Diet Pepsi. It's the same thing, dude. Okay, simply you need to go to pth node. Okay, if p is greater than the current node, then you have to go right, and root might be the say the predecessor as the root node, and then you go right. Root is equal to root dot right. Okay, if p is less than the current node, that means what? I have to move left. Okay, yeah, the left node, the current node cannot be moved with the predecessor. Simply move root dot left. I simply moved left. So let's give an example now. 5, 3, 4, 7, 8. 10. Okay, if I give you p is 10, find its predecessor. You just check p is greater than current value. Yes, you have to move to the right subnode, right subtree. What is the predecessor? Left most in a right sub tree, that is the predecessor. So you have to move right. When you move right, okay, leftmost in the right subtree. If it doesn't contain any right subtree, then it is where you moved right. Else where you moved right. So when you move right, okay, let's see, p is what? P is 10, right? What is the predecessor to 10? Here it's 8, here it's 7. that if 7 had a left child called 6, and give you p is 6, then it is 5, because this guy's right subtree doesn't exist. So current is equal to root pre is none if p value is less than the current value. Predecessor value is less than the current value, then you have to move left. While current is not equal to pre, have to move left. Simply move it. Curve is equal to curve dot left. If p is less than the current, so p is less. Okay, if p is less, in order to find, you have to move to the left subtree. Now if p is greater than here, if p is greater, then you have to move to your right subtree, but you have to save the current node. Suck is equal to, pre equal to current node, and move current node is equal to current dot right. Move, and then if p dot rightmost subtree and the leftmost subtree, same thing is doing. P dot left is less than root of all current is equal to current dot left is saving with the O. This is predecessor किधर है यार? Make changes here only, I guess. Okay, predecessor is none. While current is there, if p is less than current, so I have to move left. Simply move left. Else you need to save equal to current node, and then you move current dot right, while current is not equal to p. And if okay, you are in the p node, you need to find the predecessor. Leftmost node in the right subtree. No, rightmost node in the left subtree. Right. Left is equal to none. You will return current. No, it will return 3. Else you need to find rightmost in the left subtree, which is easy. Right. This is fine. Okay, arrange some query 2D mutable. Arrange some query to be immutable. Mutable. Mutable is a hard question. Immutable is a let's do immutable first. 10 minute approach. Come on. Given a 2D matrix, handle multiple queries of the following path. Calculate the sum of the elements of the matrix inside the rectangle defined by upper row and the lower corner. Upper right corner and the lower right corner. Okay, you have to get the sum of the elements in that row. Some region row 1 returns the sum of the upper right. No, how do you even do this, man? Some region works in one call. What is the brute force? Brute force, you simply go through each of the column and get the sum. Okay, what is this 6? Okay, let's see if I have a matrix. Three, 4. I have a bunch of elements 2, 3, 1, 4, 6, 3, 2, 1, 7, 4, 8, 5, 4, 1, 2, 1. If I want the sum of this matrix box, right? What is the sum of the first 4 rows? 2 plus 3, 2 plus 1. 6 is the sum. 6 plus 4, 24 is the sum. इसका सम 2 ही होगा. 3 sum to 6. 4, 1, 5. Doing some 2D. We'll take the sum of this box. If I take the sum of this box minus this box, कैसे करेगा यार? If I have everything pre-calculated also. Tell me the sum of this box. Somebody asks. I know the sum of this box is 24. What is the sum of this? I don't know, bro. How do you even solve this, man? What the fuck? So many combinations are possible, dude. Of 1 minute. Let's say there has to be some trick to get the sum, dude. This whole row sum I know, and this whole column sum if I know. अरे तो सो गई हो. If I ask the sum of this one, right? The big one minus the Middle one, if I do, I get the sum of only this one. कैसे करे भाई? I want the sum of this guy. I need the sum of this guy. Okay. If I know the sum of these two rows, I have no idea, man. What the fuck? कैसे करे भाई? Prefix sum का क्वेश्चन है यार. One, two, three, four. One, two, three, four. 2363. Okay, the sum of till here it is 5. If I want the sum of these, the total sum 2 3 6 3 is 9 plus 5 14. Okay, if I do 14 minus 5, I got 9 6 3, which is the sum of these two boxes. यार क्या फालतू क्वेश्चन है यार. Okay, I know it. 2D, how do you do it in 2D, man? I know the column sum, let's say. If I take the total column sum, it's 3 plus 7, 14 is the total column sum. And this is 3, 14 minus 3 is, you get the column sum till here. What is the use? Getting row and column independently. I don't know, bro. I don't know, man. Notice, we can add blank row and blank column to remove edge case statement. So we can have the following information: sum of I plus constructor 2D array, sum of row plus 1 and column plus 1. Blank column, sum of row plus 1 0 0 to remove edge case setting. So we can have the following definition: sums of I plus 1 j plus 1 represents the sum of area from 0 to matrix of ij. Okay, matrix of ij from here to here, this corner to this column makes sense. Ij represents from 0 to ij. Okay, this area, if I want to find, what do I do? Okay, wait. Sums, the idea is below. Okay, I and j. ij क्या है बे? हाँ नो आइडिया वो क्या हुआ है, कुछ भी समझ नहीं आ रहा भाई. I plus j plus 1 represents the sum of area from matrix of 0 0 to matrix of ij. Okay. ij will be equal to I minus 1j. I minus 1j. What is I minus 1j, bro? I minus 1. I don't have any idea what this guy's doing now. Picture. Show me some pictures. Okay. Some range of row 1, column 1, column 2, column 1, column row R1, C1, C2, C2. क्या लिखा है यार, गलत लिखा है. R2, C2 होना चाहिए. Okay. Equal to sum of R2, C2. The total sum minus R2, C1 minus 1. क्या बकवास है यार, ये समझ नहीं आ रहा. Running sum in the DPU matrix. Okay. I minus 1j. I minus 1j. So upper one and j I j minus 1. Same row left one. Upper one and left one का sum है उसमें. Minus dp of I minus 1 j minus 1. Whoa. If I want this sum, if I want, okay, if I want this sum, right? R1 is 1, R2 is 2, C2 is also 2. Okay, what is the formula? R1 C1 I minus 1j. Okay, dp of I minus 1j. ij power 1 is the sum of what? This whole thing. Left one is what? This whole thing. Huh. Minus the common areas. Sum R2 C2 minus sum of R2 C1 minus 1. R2 C1 minus 1. Oh. Minus sum, you subtracted it 2 times, you are adding it back. R1 C1 minus 1. Whoa. Okay, let me create this matrix neatly. The sum, this box, okay, I will take the sum of the whole blue box, okay, no, you have the sum of the blue box minus this sums, right, minus yellow box minus this blah box again. Take the sum, whole sum. ये क्या सम है बे? आईजे क्या है पहले? Sum of क्या बकवास मैट्रिक्स बना रहे हो? नहीं समझ में आ रही है।
Step into Wix Studio, the web platform for agencies and enterprises.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem range sum query 2D immutable. So we're given a two-dimensional matrix and we want to be able to handle queries that calculate the sum of a portion of this matrix. basically a submatrix. The submatrix, which, for example, something like this, is going to be defined by 2 points. The upper left point, which will be given with the row and column coordinate. So, for example, this one. And by the way, we know that there are values for the column, there are values for the particular row. So if we were given row 1, column 2, that would correspond to this point being the top left. Now for bottom right, for example, if we were given this one, row 2, column 4, we need to then calculate the sum of this little matrix, which is not hard to do. Of course, we could write a for loop, a nested for loop, starting here, going through the entire row, and then going through the entire next row. The pseudocode would look something like this, where the outer loop is going to go row by row, and the inner loop is going to go column to column in that particular row, and just keeping track of the sum, right? We're just going to add to this whatever the value is at a particular position, and then get the total, and then return that total. That's pretty easy, but we're actually going to be calculating this for many submatrices. So this one, and we could have a bunch more. We might do it for every one possibly, right? So that's not going to be super efficient. The idea behind this problem is built on top of prefix sums, and you would know that if you solved the easier version of this problem, which is range sum query 1 dimension. The summary is that if we just had 1 dimension, we wanted to calculate, okay, this portion of the array, we could do that by taking the prefix sum of this and then subtract from it this, and then we would be left with the remainder, which is this. That's what we want. Now, why do we care about prefix sums? Well, they can actually make things a lot more efficient, because we can calculate the prefix sum of this row in big O of n time, right? 3, this is also 3, this is 4. I'm just taking the previous value, adding the current value to it. So this is 8, and this is 10. We can range times n minus 1 different subarrays. So in the worst case, to calculate every subarray would have been n squared, but with prefix sums, this is big O of n time, because for any part, all the prefix more complicated, because yes, this is 2 dimensions. But it's nothing that a little bit of geometry and math can't handle. So let's say we were talking about this green square over here. We want to get the sum of this. Using the idea of prefix sums, what kind of pre-work could we use to calculate the sum of this matrix in constant time, given that we've done some pre-work? Well, assuming that we calculate the size of this, subtract from it the size or the sum of this, and also subtract from it the sum of this, we would get pretty close to the result.
I think I understand the algorithm. So let's say row 1 is 0, row 1 is 0, column 1 is, row 1 is 1 here, and total 4 to 4 8. So row 1 is 1, column 1 is 1, row 2 is 2, column 2 is 2. So sum of R1, R2, C1, C2 will be, first I need to take the sum of this whole thing. Okay, the sum of this whole thing will be okay, row 2 है इधर और column 1 minus 1 is row 2, column 1 minus 1. Okay, first thing, you take dp of r2 c2 the whole sum minus this whole sum minus this one minus this one, r2 c minus 1 minus dp of this is what c2 column 1 is 1 column 2 ये तो column 0 है, column is set to 2 r2 c minus 1 r2 क्या बकवास है यार.
But notice how we had to subtract this position twice, so then we would re-add this position to counteract that, and then we would have the sum of this portion. The good thing is we can do this, and it's actually pretty simple. The idea is that for every single point in the entire matrix,
r2 c2 r2 is the same, c is 0, which is c1 minus 1. This makes sense. Now here c2 is same, row is 0. 0 means r1 minus 1. r2 plus 1 c2 plus 1 r2 c2 r1 plus 1 c2 plus 1 minus 1.
we're going to assume that this is going to be the bottom left of a submatrix. And we're going to assume that the first point in the matrix is always going to be the top left. So we want to calculate the sum of this and store it in the bottom right corner. And we want to do that for every position in the matrix. Now, first of all, how are we even going to do that? We know that if we can do that, we can get any sum region in constant time. But how can we do the pre-work? Well, it's not too difficult. First, it's going to be just like taking prefix sums. So we're going to put a 3 here. We're going to get this prefix sum. Then we're going to get this prefix sum, this prefix sum, this prefix sum, etc., storing that prefix sum in the bottom right value. But doing it for our row is pretty easy. But then doing it for the second row is a little bit more difficult. But it's still going to use the idea of prefix sums. We're going to get this prefix sum, add to it the prefix sum that we calculated up above. What that's going to give us is this area. And if we do that here, right, we get this prefix sum and add to it the above value, which is this prefix sum, we're going to have this, right? The idea is the same for any particular point. So for example, if we want to get the value that's going to go here, well, we can get this prefix sum, and by taking the value right above it, we're going to have the entire area of this. And by getting the value that's stored right above it, we're going to get the total sum of this area. So that's actually the entire idea of this problem. There's one last little thing that I want to mention that's going to make coding this a little bit easier. Imagine if we were told to calculate, let's say this was the top left, this is the bottom right, so therefore we want to get the sum of this area. This is kind of a very simple case, but in terms of code, it's actually going to be an edge case, because what we're going to do is first we're going to get the area of this, and then we're going to try to get the area above it, but we're going to notice that the row above is out of bounds. So we're going to need like an if statement or something to kind of detect that. And also to the left, we're going to try to get the area to the left of it, but we see that the column is out of bounds. So again, we're going to need an if statement to detect that. We can get rid of these edge cases by basically having a matrix, the matrix that we calculate all those prefix sum type things in, it's going to be 1 unit larger in both directions, something like this. So these are all going to be filled with zeros. The reason why is because if we were trying to get the area of this, and then we wanted to subtract from it the top, we would look at this value and it's 0, which makes sense because really we're not subtracting anything from this area.
R2 C2 minus this one P of R. Okay, this is R1 R1 minus 1 C2 R2 we maintain and C1 minus 1. Okay, R2 we maintain, C1 minus 1, R1 minus 1 minus this plus this whole thing minus this also. I think I got this, man. They gave me the matrix. Should be able to code it in 10 minutes. Yeah, sure. Okay. Those will be equal to 1 of matrix plus 1 of 0 plus 1 self dot let's call it matrix, sum matrix into 0 into columns and range rows. Initialize them. Let's just copy all the elements and then we calculate the sum, I guess. Sum for each is the top one plus the left one. Okay, let's just copy the elements. Ij will be equal to I minus 1, j minus 1 in the matrix. You added one column and you added one row. So 1 1 will be 0 0. Yeah, I calculated this. I in range of for in range from 1 to R, so in range from 1 to column, self dot some matrix of ij will be simply what? Plus equal to sum of I minus 1 j top 1 plus some matrix is calculated. Some region will simply be self dot some matrix of row 2 column 2. Wait a second, some region कैसे देगा भाई? It will give you the original matrices, this one column plus 1, got this one. Now you have to do what? You have to get the top element. If row 2 minus 1 and column 2 minus 1 is the top element, right? So some top element is simply row minus 1, column is the same. Also here it will be row 1 column 1 plus 1 row 1 उड़ाना some matrix of row is simply like that, column is reduced by 1 plus both minus not back. What? Matrix of I minus 1 G minus 1 सही तो है यार. I minus 1 J plus I J minus 1. Some matrix, there is something wrong. Dot three is the second element. What is the matrix? 1 1 is 3. Perfect. 1 1 is 3. मैट्रिक्स ऑफ 2 2 क्या है? 6 1 8 8 प्लस 6 is 14. गलत है यार ये तो. Three 0 1 3 3 4 8. ओके 8 9 10 करेक्ट. प्रीफिक्स मैट्रिक्स बन गया है. 0 3 5 8 17 14 क्या है यार? दिस इज रॉन्ग. ऊपर में क्या था? 3. लेफ्ट में क्या है? 8. 3 and 8 should add with 6. Oh, you're not calculating the sum matrix correctly, bro. Okay, sum the way you're calculating is also wrong. Minus subtract sum matrix minus 14. 8 plus 6 is 14. Perfect, yaar. 6 by 11. 11 3 14. 15 16 17 18. Okay. Row 2 plus 1, column 2 plus 1. Okay. Oh, upper right corner we need. Wait a second. So the matrix you have, upper right corner will be given by what? The row 2 column minus 1. Row 2 column 1 minus 1. Row 2 column 1 minus 1, and the left will be given by what? Row 1. Wait. क्या कितना मुश्किल कैसे हो सकता है? Okay, we need this one, right? I need this one. This is row 2 column 1 minus 1. Row 2 column 1 minus 1. Perfect. This is again row 2 wait, but this one is this guy's sum is where, man? It's simply here. What is this? If you have like this, what is this? Row 2 column 2. This is row 1 minus 1 column 2. This is column is matching with the 2 and row is row 1 minus 1. Row 1 minus 1 column 2, and here the row 2 okay, this is done. This is row 2 plus 1. Okay, this is second row is matching. Column is what? Column is column 1 minus 1. Column 1 minus 1. Row 1 column 1. increase, then it's a lot clearer to you. Okay. Then some query 2D mutable. Given 2D matrix handle multiple queries for the following type. Added the value cell in the matrix. Calculate the sum of the elements matrix inside the rectangle defined by upper left and outer. So mutable. You can change the value of the cell of a cell in matrix. Huh. So you can update the value and you can also what? ना मैट्रिक्स सम रीजन को उठाया, सम रीजन कहाँ का लिया हुआ है? 2 1 4 3 0 1 2 3 4 2 1 4 3. He queried the sum. He got the sum as 3 4 5 6 7 8. He got the sum as 8. Then he updated 3 to 2. So third row 0 1 2 3, second column. This one 0, he changed to 2. Okay, if you change one element, the whole this inside whole matrix need to be recalculated, right? No. If I change this number, right, this matrix doesn't change. This one, nothing has changed around this. If I change one number, right, change this number. Okay. One, two, three, 5 5 है. 1 2 3. You can't. Where is my image, man? How do you rotate this? इसको घुमाएं कैसे? Oh, nice. Wow, I can draw perfect lines now. Wow. यार ये तो लाइन टाइम लग रहा है ना कि range some query to be mutable. Okay. 1, 2, 3, 4, 5. Okay, let's start from here, man. 1, 2, 3, 4, 5. Okay, the sum for 3 is 3 only. Plus 0 is 3 only. 3 plus 1 is 4, 8. 3 plus 2 is 10. Now here 5. 5 plus 3 is 8. Okay. यार ये कैलकुलेट हाथ से कैलकुलेट करना भी मुश्किल है यार. Okay, 8 plus 3 minus 3, so 8 only. 11 plus 3 is not 8 यार, गलत है तो. 8 plus 3 minus 3 is 8, right? Oh wait, 8 plus 3. Okay, makes sense. 8 plus 6. 8 plus 3 minus 3 plus 6. This is difficult. 8 plus 3 plus 6 minus 3. Okay, 6. 7, 8, 9. 9 plus 8. 17 minus 3. 14. I can calculate manually only faster. 3, 4, 10, 13, 18. यार ये नंबर चेंज किया तो how does it affect the thing? Here anything wouldn't have changed. Here also nothing will change. I think these values need to be updated again. Recalculate from here to here, I guess. Yep. $500,000 calls will be made. Just need to. Will that TLE though? Let's use the same code. कहाँ गया यार मेरा immutable? अभी तो सबमिट किया ना रे. If they update 0, 0, then what is the point, man? You have to recalculate the whole matrix. भाई पूरा सिस्टम बढ़ा दिया यार इसने. I don't know, bro. Binary index tree. Oh, it's a completely different thing, dude. Fenwick tree. Below is the responsibility matrix of a 2D binary index tree. Fenwick tree. Let's see what this guy is teaching.
Hello friends, my name is Tushar and today I'm going to talk about Fenwick tree or binary index tree. Before going into the details of what Fenwick tree is, let's look at the use case which Fenwick tree is trying to solve. So Fenwick tree is used to get prefix sum of an array. For example, if I'm given an array of 7 elements from 0 to 6, so Fenwick tree will help me answer queries like, what is the sum from 0 to 4? So the sum from 0 to 4 is 3 plus 2, 5, 5 plus 6, 11, 11 plus 5, 16. What is the sum from 0 to 6? So the sum from 0 to 6 is 16 minus 1, 15 plus 2, 17. So queries like this is why I use Fenwick tree. What are the other alternate solutions if we did not use Fenwick tree? One solution is to keep a prefix sum based array. So for 0, it's the sum till 0 is 3. For 1, the sum till 1 is 3 plus 2, 5. For 2, the sum till 2 is 5 plus 0, 5. Sum till 3 is 5 plus 6, 11. Sum till 4 is 11 plus 5, 16. 16 minus 1, 15. And 15 plus 2, 17. And this would also help me answer the same query. What is a sum from 0 to 4? And you directly go here and that's 16. What is a sum from 0 to 6? And that's 17. But the problem with this approach is if there are many updates in the original array, it takes, for every update, it takes O of n time to update this, this array. So if an array is large and if there are many updates in an array, this prefix sum based array doesn't scale very well. Another possible alternate is to use segment tree. If you don't know what segment tree is, I have another video.
Segment tree क्या था यार? Segment tree. AVL tree, I know. I don't know what is a segment tree. It's a balancing binary search tree.
You can watch that video. The problem with segment tree is it's slightly more complicated. It takes, in worst case, 4 of n space to store segment tree for n elements in an array, and in worst case it takes 4 of log n time to search into to do a range sum query in a segment tree for an array of size length n. So this is where Fenwick tree comes into the picture. The space it takes to store Fenwick tree is O of n. The amount of time it takes to search into Fenwick tree is O of log n. The amount of time it takes to update every element in Fenwick tree is O of log n. And the amount of time it takes to create a Fenwick tree for the first time is n log n. Next,
इंसर्शन का कॉम्प्लेक्सिटी क्या है यार? Rotations are of 1, so log n time. Insertions are log n.
So by subtracting,
let's look at the implementation details of Fenwick tree. So now I'm going to create a Fenwick tree based on a given array. So I'm given an array of 11 elements starting from index to 10, starting from index 0 to 10. So my Fenwick tree will go from index 0 to 11, one more node than the actual array. So let's see how I built this tree right here. So this is a conceptual tree. My actual tree will be stored in a form of array, but this is easier to understand, which is why I have it this way. So 0 is a dummy node and doesn't store any information, and rest of the nodes 1 to 11 will store the prefix sum. Why I have the tree this way? Let's look at it. Why 0 is parent of 2? If you look at the binary representation of 2, that's 1 0, and if you flip the rightmost set bit, it becomes 0 0, which is 0. Which is why 0 is parent of 2. If you look at binary representation of 8, that's 1 0 0 0. If you flip the rightmost set bit, it becomes 0 0 0 0, which is again 0, which is why 8 parent is also 0. If you look at 10, binary representation of 10 is 1 0 1 0. If you flip the rightmost set bit, it becomes 1 0 0 0. And this is 8, which is why 10's parent is 8. Let's look at 11. 1, 0, 1, 1. If you flip the rightmost set bit, it becomes 1, 0, 1, 0. This is 10, which is why 10, 11's parent is 10. So hopefully it is clear why our tree looks like this. To get the parent, all you have to do is get the binary representation, flip the rightmost set bit, and then it gets a parent. Later on, we will look at how you can efficiently flip the rightmost set bit. Now let's try to fill up this tree here with the prefix sum information. One thing to notice is that every number can be represented as a sum of power of 2's. For example, 10 is 2 raised to 3 plus 2 raised to 1. 11 is 2 raised to 3 plus 2 raised to 1 plus 2 raised to 0. 5 is 2 raised to 2 plus 2 raised to 0. So Fenwick tree uses this information to store the prefix sum. Let's see how this works. As I said, 0 is a dummy node, so the only information it has in its node is 0. Let's start with 1. 1 can be represented as 0 plus 2 raised to 0. So what I'm saying is, in my original array, starting from index 0, the sum of next one element will be stored at 1, so 3. And I'm indicating that the range sum of range 0, 0 is stored at 1. Let's look at 2. 2 can be represented as 0 plus 2 raised to 1. So again, starting from 0, the sum of next two elements will be stored at 2. So 3 plus 2 is 5, and this is 0, 1. Let's look at 3. So in my original array, starting from index 2, the sum of next one element will be stored at 3. So that's minus 1, and this is 1. This is 2, 2. 4. 4 is 0 plus 2 raised to 2. So starting from 0, the sum of next 4 elements will be stored at 4. So 3 plus 2 is 5, 5 minus 1 is 4, 4 plus 6 is 10. So 10 is stored at 4, and this is 0, 3. Let's look at 5. 5 is 2 raised to 2 plus 2 raised to 0. So starting from 4, the sum of next one element will be stored at 5. So 5, and this is 4, 4. 6. 6 is 2 raised to 2 plus 2 raised to 1. So starting from 4, the sum of next two elements will be stored at 6. So that's 9. And this is 4, 5. Let's try to fill up 7. 7 is 2 raised to 2 plus 2 raised to 1 plus 2 raised to 0. If you combine this two, starting from 2 raised to 2 plus 2 raised to 1, so starting from 6, the sum of next one element will be stored here. So that's minus 3. And this is storing 6, 6. Let's look at 8. 8 is 0 plus 2 raised to 3. So starting from 0, the sum of next 8 elements will be stored at 8. So that's 5. 5 minus 1 is 5 minus 1 is 4. 4 plus 6 is 10. 10 plus 5 is 15. 15 plus 4 is 19. 19 minus 2 is 16. And 16 plus 3 is 19. So that's 19. And this is 0, 7. 9. 2 raised to 3 plus 2 raised to 0. So starting from 8, the sum of next one element will be stored here. So that's 7. And we'll say 8, 8 is here. 10. 2 raised to 3 plus 2 raised to 1. So starting from 8, the sum of next two elements will be stored here. So that's 9. And that's 8, 9. And finally 11. 2 raised to 3 plus 2 raised to 1 plus 2 raised to 0. So starting from 8 plus 2, 10, the sum of next one element is stored here. The range is 10, 10. Alright, so hopefully you understood how I created this tree. I did not show you the efficient way of creating this tree, but hopefully this gives you an idea how I filled up the nodes of this tree using the prefix sum. So next, let's look at how we are going to search into this binary index tree. So our aim is to get the prefix sum given a range. So for example, give me the prefix sum from 0 to 5. So we want to get this prefix sum 0 to 5. So to get the prefix sum, you got to start from node 6. Because the end is 5, you start from 6. You go to node 6, you take that value 9, so the value here, so 9, plus you go to its parent. So to go to the parent of 6 from 4, all you have to do is flip the rightmost set bit. So you come here, so that's 10. And then you flip the rightmost set bit and you reach 0, so that doesn't add anything, so 19. So 19 is the sum from 0 to 5 in my original array. So let's look at another example. Let's try to get sum from 0 to 9. So 0 to 9, so since this is 9, I'll start from the 10th node in my Fenwick tree. So I start from 10. So the value here is 9, plus I go to its parent, so that's 19, and then I go to its parent, so that's 0, so that doesn't add anything, so this is 28. So the sum of 0 to 9 will be 28. Why this works is, let's see why it would work. If we're trying to get the sum from 0 to 9, we know that this 10th node here is storing the range 8, 9. So 8, 9 of this 0 to 9 is stored at 10. Also, we know that its parent 8 is storing the range, sum of range 0 to 7. Sum of range 0 to 7 is stored at 8. So is 7 plus 8, 9, which is 8, 9 plus 19. Let's look at another example. So I was trying to get the sum from 0 to 7. So I start from 8th, so I was trying to get a sum from 0 to 6, for example. So I'll start from the 7th index. So 7 stores the sum of 6, 6. So this is coming from 7, so that's minus 3. Then I go to its parent, so that's 6. And 6 is storing the sum of 4, 5. So this is coming from here, and this is 9. Then I go to its parent, 4, and 4 is storing the sum of 0 to 3, and that's 10. So this value here is 16. So this is how we get the sum of 0 to 6 by getting the sum of 0 to 3, getting sum of 4 to 5, and getting the sum of 6. The amount of time it will take to get the prefix c will be the height of the binary, height of this binary index tree, and in worst case the height of this binary index tree will be O of log n. So the amount of time to get the prefix sum will also be O of log n. Next, let's look at how we are going to actually enter the values in this binary index tree in an efficient way, and how we are going to update the values in this binary index tree. Let's quickly look at how we are going to get a parent of a node. So I have the steps right here. Get this 2's complement of a number, and this with the original number, and then subtract that result from the original number. Let's try to get a parent of 7. So binary representation of 7 is 1, 1, 1. 2's complement of 7 will be 0, 0, 0. Flip all the bits and then add 1 to it, so that's 2's complement, so that's 0, 0, 1. Then AND this 0, 0, 1 with this 1, so that's 1, 1, 1, 0, 0, 1. So this is 0, 0, 1. And then subtract this result from here, so 1, 1, 1 minus 0, 0, 1. So that's 6, which is why 7th parent is 6. Let's try another example. Let's try to get binary representation, try to get the parent of 10. So binary representation of 10 is 1, 0, 1, 0. 2's complement of 10 is 0, 1, 0, 1 plus 1. So this is 0, 1, 1, 0. Subtract and this with this. So this becomes 1, 0, 1, 0 and then 0, 1, 1, 0. So this is 0, 1, 0, 0. And then subtract this from this. So 1, 0, 1, 0 minus 0, 0, 1, 0. So this is 1, 0, 0, 0. So that is 8, which is why 10's parent is 8. To get the parent, all you do need to do these 3 steps, and that is an O of 1 operation. So to get the parent is O of 1 operation. Next, let's look at how we are going to fill up this table. Previously in the video, I showed you how I filled up this binary index tree from the original array. Let's try to do that efficiently this time. So we know that 0 doesn't store any information, so the only thing it has here is 0. Let's start from 1. So when I'm trying to fill 0, I try to fill 0 plus 1, so 1th node in my binary index tree. So I come here, I make whatever values here, we add 3 to it, so this becomes 3. But updating this 1 is not enough. You have to also update all the other nodes which could be affected. And to get those nodes, we'll use this formula get next. So let's start from 1. So 1 is, the binary representation of 1 can be written as 0, 0, 0, 0, 0, 0, 0, 1, assuming that we are storing 1 byte to store this information. So 2's complement of 1 is 1, 1, 1, 1, 1, 1, 1, and 1. If you add them together, this becomes 0, 0, 0, 0, 0, 0, 0, 1. And if you add this to the original number, that becomes 2. So you go to 2, and you whatever value is set at 2, you add this number to that. So this becomes 3. Then find the next number that needs to be updated, next node which needs to be updated. So we repeat the same process again of get next. So 2's 2 can be represented as 0, 0, 0, 0, 0, 0, 1, 0. 2's complement of this is 1, 1, 1, 1, 1, 1, 0, and 1. And if we 0, 1, so 1, 0. If we AND it with the original number, this becomes 0, 0, 0, 0, 0, 1, 0. So this is 2. So we add this 2 to the original number, so we go to 4, and whatever number is there, we add this 3 to that guy, so that becomes 3. Then we again use the same formula, 4, 4, and get the next.
Have you taken your SATs yet? No. Why not? You know the SATs increase your chances to getting a scholarship, right?
हेलो दोस्तों, तो आज हम कवर करने वाले हैं यार बाइनरी इंडेक्स ट्रीज का टॉपिक. इसको फेनविक ट्रीज भी बोला जाता है. तो बाइनरी इंडेक्स ट्रीज यार एक ऐसा टॉपिक है जो इंटरव्यूज में इतना नहीं पूछा जाता है, बट कभी कभी कुछ कंपनीज जिनका इंटरव्यू हल्का सा डिफिकल्ट रहता है उनमें पूछा जाता है. जैसे कि डायरेक्ट टाइम में इसका एक इंटरव्यू राउंड में क्वेश्चन आ चुका है, मैंने देखा हुआ है. एंड फोन पे के भी इंटरव्यूज में एक बार मेरे एक दोस्त को पूछा गया था. बाइनरी इंडेक्स ट्रीज एक ऐसा टॉपिक है जो इतना डिफिकल्ट नहीं है, एंड अगर आप इसको एक बार समझ लोगे ना तो इसका कोड बहुत छोटा होता है, एंड इंटरव्यू के कोडिंग राउंड्स में आप फटाफट लिख सकते हो. सेगमेंट ट्रीज के काफी सारे क्वेश्चन हैं जो बाइनरी इंडेक्स ट्रीज से हो सकते हैं, एंड इसलिए इसका काफी फायदा है क्योंकि इज इक्वल टू एक्स करना है, रिप्लेस करनी है किसी वैल्यू को. दूसरी टाइप की क्वेरी है, मेरे को L to R का सम चाहिए एरे में. अगर आप नेइव मेथड से इसको सॉल्व करने की कोशिश करोगे तो ये आपको TLE एरर दे देगा, नॉर्मल कोड. तो ये जनरली सेगमेंट ट्री से सवाल होता है, बट बाइनरी इंडेक्स ट्री से इसको हम काफी छोटे में कर सकते हैं. तो ऐसे क्वेश्चंस के लिए हमें बाइनरी इंडेक्स ट्रीज चाहिए रहता है. तो देखते हैं कि यार बाइनरी इंडेक्स ट्रीज होता कैसे है. तो यार बाइनरी इंडेक्स ट्रीज सीखने से पहले हमें एक बिट मैनिपुलेशन की छोटी सी टेक्निक सीखनी पड़ेगी. वो टेक्निक क्या है कि यार अगर हमें एक नंबर दिया गया है x, अब इस x की बाइनरी रिप्रेजेंटेशन में मेरे को राइट मोस्ट बिट फाइंड करनी है जो सेट है. बेसिकली लेट्स से इस कोई नंबर है जिसकी बाइनरी रिप्रेजेंटेशन ये है, ठीक है. अब इस नंबर में मेरे को राइट मोस्ट सेट बिट फाइंड करनी है, यानी कि ये बिट की पोजीशन फाइंड करनी है, ठीक है. तो इसकी एक बिट से बहुत सिंपल सी टेक्निक होती है, हम वो टेक्निक देखते हैं. लेट्स से x इज इक्वल टू A1B. A यहाँ पे कोई भी एक रैंडम बाइनरी नंबर है. 1 जो है राइट मोस्ट सेट बिट है, एंड B सारे 0 है, ठीक है. B सारे 0 है क्योंकि अगर ये राइट मोस्ट सेट बिट होगी तो B's ऑब्वियसली सारे 0 होंगे. तो किसी भी बाइनरी नंबर को मैं एक ऐसे रिप्रेजेंट कर सकता हूँ A1B की फॉर्म में, जिसमें A कोई भी एक रैंडम नंबर है, बाइनरी नंबर, 1 राइट मोस्ट सेट बिट है और B सारे 0s हैं. अब अगर मैं निकालूं माइनस एक्स किसके बराबर होगा? माइनस एक्स 2's कॉम्प्लीमेंट ऑफ x के बराबर है. अब वो कैसे होता है? 2's कॉम्प्लीमेंट ऑफ x क्या होगा? x कॉम्प्लीमेंट प्लस 1, ठीक है. तो ये माइनस एक्स इक्वल टू 2's कॉम्प्लीमेंट ऑफ x, ये एक फॉर्मूला होता है. तो 2's कॉम्प्लीमेंट x कॉम्प्लीमेंट प्लस 1 के बराबर है. अब इसमें अगर x की वैल्यू सब्स्टिट्यूट कर दें, A1B, राइट. अब इसका कॉम्प्लीमेंट प्लस 1. अब आप देखोगे a का कॉम्प्लीमेंट क्या हुआ? a कॉम्प्लीमेंट 1 को कॉम्प्लीमेंट करेंगे तो 0 आ जाएगा, b को कॉम्प्लीमेंट करेंगे तो देखो b सारे 0s है, तो ये एक ऐसी स्ट्रिंग बन जाएगी जिसमें सारे 1 हो, राइट, +1। अब इसमें अगर मैं 1 ऐड करूंगा तो ये 1 इससे मिलके 0 हो जाएगा और वो 1 कैरी में चला जाएगा, ये 1 उस 1 कैरी वाले 1 से मिलके 0 हो जाएगा, तो ये सारे नंबर जो है ये 0 हो जाएंगे और 1 अल्टीमेटली यहां पे कैरी में आ जाएगा, तो ये 1 0 से ऐड होके 1 हो जाएगा और ये a कॉम्प्लीमेंट है। ये चीज किसके बराबर है? b के बराबर। तो ये किसके बराबर हो जाएगा? a कॉम्प्लीमेंट 1 b के बराबर। तो -x किसके बराबर आ गया? a कॉम्प्लीमेंट 1 b के बराबर और x है a1b। तो यार अब हम कैलकुलेट करेंगे x एंड -x की वैल्यू। तो अगर x मेरा ये है a1b, -x मैंने कैलकुलेट किया, मेरा क्या आ गया? a कॉम्प्लीमेंट 1b। अब इन दोनों का अगर एंड कर दूं मैं तो मेरे पास क्या आएगा? b सारे जीरोस हैं, b और b ये सारे जीरोस बन जाएंगे, ठीक है ना, ये सारी एक जीरोस की स्ट्रिंग होगी। a और a कॉम्प्लीमेंट का एंड क्या होगा? a में अगर 1 जहां पे भी होगा, a कॉम्प्लीमेंट में वहां पे 0 होगा, तो इन दोनों का एंड भी 0 हो जाएगा और 1 का एंड क्या हो जाएगा? 1। तो आप देखोगे कि x एंड -x ये मेरे को एक ऐसा नंबर दे रहा है जिसमें सिर्फ राइट मोस्ट बिट जो है x की वो
Only for once it is 1.
सेट है। तो x एंड -x में कोई एक ऐसा नंबर देगा जिसमें सिर्फ राइट मोस्ट बिट जो x की है वो सेट होगी, ठीक है। और अगर अब हमें x में से उसकी राइट मोस्ट बिट हटानी है तो हम क्या करेंगे? x -x एंड -x।
मैंने देखा कि एक गधे से गधा मालिक सिर्फ दिन के 100 रुपए कमाता है और उसके लिए उसके ऊपर 50 से 60 किलो का वजन लाद के काम करवाता है। उसके बाद उनको छोड़ देते हैं सड़क पे। एक्सीडेंट हो रहे हैं उनके, लंगड़े हो गए हैं, अंधे हो चुके हैं।
राइट, तो इससे क्या होगा? मेरी राइट मोस्ट बिट हट जाएगी x में से। तो अभी हमने देखा कि राइट मोस्ट सेट बिट कैसे निकालेंगे x की? x एंड -x से। और रिमूव कैसे करेंगे? x एंड -x। तो इसको एक एग्जांपल से देख लेते हैं। तो अगर लेट्स से मैं 6 की बाइनरी लेता हूं तो 6 की बाइनरी क्या है? 1 1 0। अब इसका -6 की बाइनरी क्या होगी? 0 0 1 +1, राइट। वो किसके बराबर हो गया? 0 1 0। अब ये x है, ये -x है। अब इन दोनों का एंड करूंगा, x एंड -x। ये किसके बराबर आ जाएगा? 0 से 0 0 हो जाएगा, 1 और ये 0। तो 6 की राइट मोस्ट बिट ये थी और वो मेरे को मिल गई। अब इसमें से मेरे को ये बिट निकालनी है, तो कैसे करूंगा? x -x एंड -x। तो 1 1 0 -0 1 0, तो क्या मिल जाएगा मेरे को? 1 0 0। तो लास्ट सेट बिट मैंने निकाल दी ऐसे। तो यार अब आते हैं बाइनरी इंडेक्स ट्रीज पे। तो बाइनरी इंडेक्स ट्रीज के लिए सपोज हमें गिवन है एक
x minus x and minus
ए एरे गिवन है जिसका साइज है n। अब एक बीआईटी एरे मान लेते हैं जिसमें लेट्स से अभी 13 एलिमेंट्स अज्यूम करते हैं, ठीक है। अब बाइनरी इंडेक्स ट्रीज को यार अगर तुम एज ए ट्री इमेजिन करोगे तो थोड़ा डिफिकल्ट हो जाता है उसको समझना। तो हम थोड़े डिफरेंट तरीके से बाइनरी इंडेक्स ट्रीज को समझेंगे। तो पहले हम देखेंगे कि यार बाइनरी इंडेक्स ट्रीज में स्टोर कैसे होती है चीजें। तो बाइनरी इंडेक्स ट्रीज में जो हर एक इंडेक्स है वो एक पार्शियल सम स्टोर करता है। तो अगर 8 या 9 इंडेक्स है या 10 इंडेक्स है तो ये सारे इंडेक्स किसी रेंज, पार्शियल रेंज के सम को स्टोर करेंगे। तो वो किस रेंज को स्टोर करेंगे वो कैसे पता चलेगा? सपोज मेरा एक नंबर है i, राइट, और एक नंबर है j। अब जो i है वो एरे का एक इंडेक्स है। j को हम डिफाइन कर देते हैं एज रिमूव लास्ट बिट ऑफ i, ठीक है। अब कोई भी ith इंडेक्स बीआईटी एरे का वो किस रेंज का सम स्टोर करेगा? j + 1 to i कोई भी ith इंडेक्स BIT एरे का j+1 से लेके I तक का सम स्टोर करेगा।
Okay, remove the last bit of I and then from j+1 to I.
तो बेसिकली BIT ऑफ I ये क्या स्टोर करेगा, j+1 से लेके I तक का सम। और j क्या है, एक ऐसा नंबर जो I की लास्ट बिट रिमूव करके मिलेगा। बेसिकली j किसके बराबर है, I माइनस I एंड माइनस I। ये हमने अभी देखा था कि कैसे निकालते हैं, राइट। तो इसको थोड़ा एग्जांपल से देखते हैं अभी। तो लेट्स से सपोज मेरे पास 13 है, सो BIT ऑफ 13 में क्या स्टोर होगा, तो 13 की बाइनरी क्या है, 13 की बाइनरी है 1101। अब इसकी लास्ट मोस्ट बिट निकाल दूंगा मैं, तो क्या मिलेगा 110, है ना, ये मिलेगा मेरे को। ये किसके बराबर है, 12 के बराबर। और 12 प्लस 1 क्या है, 13। सो BIT ऑफ 13 क्या स्टोर करेगा, 13, है ना, ये मिलेगा मेरे को। ये किसके दूंगा मैं, तो क्या 13 की बाइनरी है 1101। अब इसकी लास्ट मोस्ट बिट निकाल दूंगा मैं, तो क्या मिलेगा 110, है ना, ये मिलेगा मेरे को। ये किसके बराबर है, 12 के बराबर। और 12 प्लस 1 क्या है, 13। सो BIT ऑफ 13 क्या स्टोर करेगा, 13 से 13 का सम, ठीक है।
Okay, j+1 to I. Okay.
अब 12th इंडेक्स के लिए देखते हैं। अगर इसमें से भी मैं लास्ट बिट हटा दूं तो क्या आएगा मेरे पास, 100। ये किसके बराबर है, 8 के, है ना। 8 प्लस 1 क्या होगा, 9। तो BIT ऑफ 12 क्या स्टोर करेगा, 9 to 12 का सम। 12 क्या I है, J क्या, j+1 क्या आ गया, 9 आ गया, J 8 था। तो 9 से 12 का सम स्टोर करेगा BIT ऑफ 12, ठीक है। तो ऐसे ये डिफरेंट इंडेक्स। तो इसमें 13 क्या आ गया, 13 to 13 का सम स्टोर कर रहा है। 12 क्या स्टोर कर रहा है, 9 to 12 का सम स्टोर कर रहा है। 11 की बाइनरी क्या है, 1011। इसमें से 1 हटा दूंगा तो क्या मिलेगा, 1010। और इसमें ये किसके बराबर है, ये 10 के बराबर है। तो 11 क्या स्टोर करेगा, 11 से 11 का सम, क्योंकि J10 आ गया, ठीक है। तो 11 से 11 का करेगा। अब 10 की बाइनरी क्या है, ये है, राइट। अब इसमें से लास्ट बिट हटा दूं तो 10 क्या स्टोर करेगा, इसमें से लास्ट बिट हटा दूंगा तो क्या मिलेगा, 8 प्लस 1 क्या है, 9। तो ये क्या स्टोर करेगा, 9 से 10 तक का सम। तो ऐसे सारे इंडेक्सेस किसी पार्शियल सम को स्टोर करेंगे। तो अभी हमने देखा कि यार BIT के सारे इंडेक्सेस एक पार्शियल सम को स्टोर कर रहे हैं। तो कोई भी ith इंडेक्स जो है वो क्या स्टोर कर रहा है, अगर हम उसमें से उसकी लास्ट बिट हटा दें, राइट। अगर I इंडेक्स है तो J क्या है,
वाह,
एक ऐसा नंबर I में से लास्ट बिट हटा के जो नंबर मिलेगा उसको J बोलते हैं। तो J+1 से लेके I तक का सम स्टोर होता है BIT ऑफ I में। तो लेट अस सपोज यार ऐसा एक BIT एरे हमारे पास बना हुआ है, ऑलरेडी बना पड़ा है। तो अगर मेरे को 1 से लेके किसी ith इंडेक्स तक का सम निकालना है तो मैं कैसे निकालूंगा, ठीक है। लेट से मेरे को 1 से लेके 13 तक का सम निकालना है, तो मैं कैसे निकालूंगा, पहले तो मैं BIT ऑफ 13 ऐड कर दूंगा। BIT ऑफ 13, राइट। अब 13 में क्या है, 13 से 13 का सम है ना। अब मैं क्या करूंगा, 13 में से उसकी लास्ट बिट निकाल दूंगा। तो 13 की बाइनरी क्या थी हमारे पास, 1101। इसकी लास्ट बिट निकाल दी 12 आ गया मेरे पास। अब मैं इसमें ऐड कर दूंगा BIT ऑफ 12। अब BIT ऑफ 12 क्या स्टोर कर रहा है, 9 से 12 का सम, ठीक है। अब 12 से भी हम उसकी लास्ट बिट हटा देंगे। 12 की बाइनरी क्या थी, अब इसकी लास्ट बिट हटा दी तो हमें क्या मिल गया, 8। तो अब मैं क्या करूंगा, BIT ऑफ 8 ऐड कर दूंगा। अब BIT ऑफ 8 में किसका सम है, BIT ऑफ 8 में किसका सम होगा, 8 किसके बराबर है, 100। इसकी लास्ट बिट हटा देंगे, 0 मिल जाएगा, उसमें 1 ऐड करेंगे। तो बेसिकली BIT ऑफ 8 में 1 to 8 का सम स्टोर होगा। तो ये तीन नंबर ऐड करके मेरे को 1 to 13 का सम मिल गया, तो अब इसको कोड की फॉर्म में कैसे लिखेंगे? लेट्स से एक फंक्शन है जो इंट रिटर्न करता है, राइट? सम, हमें सम क्या निकालना है? ith इंडेक्स तक, इंट i। एक सम डिफाइन कर देंगे, इंट आंसर इज इक्वल टू 0। लेट जो BIT एरे है वो मेरा ग्लोबली डिफाइंड है ऑलरेडी, तो मैं क्या करूंगा? फॉर लूप लगाऊंगा i में से उसकी लास्ट बिट हटाता जाऊंगा और जो BIT ऑफ i है वो ऐड करता जाऊंगा। तो फॉर i कब तक? i जब तक 0 से बड़ा है। i में से हटाना क्या? उसकी लास्ट बिट हटानी है हर बार, तो क्या करूंगा? i माइनस इज इक्वल टू i एंड माइनस i। ठीक है, ये फॉर लूप हो गया। इसमें आंसर में क्या करूंगा? आंसर में कर दूंगा ऐड BIT ऑफ i।
keep removing the minus bits.
और यहां पे क्या कर दूंगा? रिटर्न तो आप देख रहे हो ये कितना इजी है। सपोज कि हमारे पास ऑलरेडी एक BIT एरे कंस्ट्रक्टेड है, ठीक है, तो उसका सम निकालना कितना इजी है। सिर्फ 5 लाइन में हम किसी ith इंडेक्स तक का सम निकाल सकते हैं।
Okay, when you take out the last bit of 8, what happens? 8 is 1000, you take out the last bit, it becomes 0. Okay.
अब इसकी कॉम्प्लेक्सिटी क्या होगी इस फंक्शन की? ये इसकी कॉम्प्लेक्सिटी उतनी ही होगी जितनी बार फॉर लूप चल रहा है। अब फॉर लूप में आप देखोगे कि i में हर बार एक बिट हटा रहे हैं हम, तो जितनी बिट्स हटा सकते हैं किसी नंबर में से उतना ही कॉम्प्लेक्सिटी होगा, उतनी बार फॉर लूप चलेगा। तो एक नंबर अगर i है उसमें कितनी बिट्स हो सकती है मैक्सिमम? log ऑफ i, राइट? तो ये फॉर लूप कितनी बार मैक्सिमम चल सकता है? अगर सारी बिट्स भी सेट थी और सारी बारी बारी से हम हटा दे तो मैक्सिमम तो ये फॉर लूप log ऑफ i बार ही चलेगा। तो इस फंक्शन की जो कॉम्प्लेक्सिटी है वो O ऑफ log n हो गई, अगर n एरे का साइज है हमारा, राइट? अब हमें अगर किसी L2R का सम निकालना है तो कैसे निकालूंगा? इस फंक्शन को कॉल करूंगा सम ऑफ R माइनस सम ऑफ L माइनस 1। तो L2R का सम क्या होगा?
Power BI is very hard. I will never be able to learn it. Well, worry no more.
Sum of R minus sum of L minus 1, ये L2R रेंज का सम होगा हमारे लिए। तो अब हम देखेंगे यार BIT एरे कंस्ट्रक्ट कैसे करना है। तो यार जो BIT एरे है इनिशियली उसकी सारी वैल्यूज जो है 0 होंगी, तो हम अगर कोई भी ith इंडेक्स पे कोई वैल्यू ऐड करना चाहते हैं, लेट्स से हमें i इंडेक्स पे x वैल्यू ऐड करनी है, तो हम वो कैसे करेंगे? तो यार जैसे हम देख रहे हैं कि यार 13 में 13 से 13 का सम स्टोर्ड है, 12 में 9 to 12 का सम स्टोर्ड है, का सम होगा हमारे लिए। तो अब हम देखेंगे यार L-1, ये L2R रेंज का सम होगा हमारे लिए। तो अब हम देखेंगे यार BIT एरे कंस्ट्रक्ट कैसे करना है। तो यार जो BIT एरे है इनिशियली उसकी सारी वैल्यूज जो है 0 होंगी, तो हम अगर कोई भी ith इंडेक्स पे कोई वैल्यू ऐड करना चाहते हैं, लेट्स से हमें i इंडेक्स पे x वैल्यू ऐड करनी है, तो हम वो कैसे करेंगे? तो यार जैसे हम देख रहे हैं कि यार 13 में 13 से 13 का सम स्टोर्ड है, 12 में 9 to 12 का सम स्टोर्ड है। तो अगर अब मेरे को 13 इंडेक्स पे x ऐड करना है, तो मेरे को उन सभी इंडेक्सेस पे भी x ऐड करना पड़ेगा जिनकी लास्ट बिट रिमूव करके 13 उनकी रेंज में आ रहा होगा, राइट? तभी तो ये BIT एरे पूरा बन पाएगा। तो मैं कहना क्या चाह रहा हूँ, लेट्स से हमारे पास 13 है, राइट? तो 13 की बाइनरी क्या है? 1 1 0 1। अब मेरे को करना क्या है? 13th इंडेक्स पे मेरे को x ऐड करना है, तो अब मेरे को उन सभी इंडेक्सेस पे x ऐड करना पड़ेगा जिनकी लास्ट बिट हटाने के बाद 13 उनकी रेंज में आ रहा हो। अब वो नंबर कैसे मिलेंगे? लेट्स सपोज 14 है, राइट? 14 की बाइनरी क्या है? 1 1 0। अब 14 की लास्ट बिट हटा दूं मैं तो क्या आएगा मेरे पास? 1 0 0। तो 14 जो है 14 ये 12 के बराबर है, तो 14 क्या करेगा? 13 से 14 का सम स्टोर करेगा, राइट? तो मेरे को अगर मैं 13 में x ऐड करना चाहता हूं तो मेरे को 14 में भी ऐड करना पड़ेगा, राइट? 15 की बाइनरी क्या है? 15 की बाइनरी है हमारे पास 1 1 1 1। अब इसमें से लास्ट बिट मैं हटा दूं तो मेरे को क्या मिलेगा? 1 1 0। अब ये किसके बराबर है? ये 14 के बराबर है। तो 15 क्या करेगा, 15 से 15 का सम शोर करेगा, है ना, 14 + 1 to 15 का सम शोर करेगा। तो 15 में से लास्ट बिट हटा के मेरे को 13 रेंज में नहीं आ रहा है, तो उसमें मेरे को ऐड नहीं करना है x, क्योंकि वो उसकी लास्ट बिट हटाने के बाद उसकी रेंज में ही नहीं आ रहा है। तो वो सारे नंबर्स जिनकी लास्ट बिट हटाने के बाद 13 उनकी रेंज में आएगा, तो वो सारे नंबर्स हमें कैसे मिलेंगे, हम बस लास्ट सेट बिट ऐड करते जाएंगे। तो हमने इसकी लास्ट सेट बिट ढूंढी, ये है। अब इसमें मैं क्या कर दूंगा, इसकी लास्ट सेट बिट ऐड कर दूंगा, तो मेरे पास क्या आ गया, 1 1 1 0 14 आ गया। अब देखोगे कि 14 की अगर लास्ट बिट रिमूव कर दे तो मेरे को 13 रेंज में आएगा, क्योंकि 14 क्या स्टोर कर रहा है, 14 स्टोर कर रहा है 13 से 14 का सम, राइट। अब इसकी लास्ट बिट 1 0 14 आ गया, क्या आ गया। अब इसमें मैं क्या कर दूंगा, इसकी लास्ट सेट बिट ऐड कर दूंगा, तो मेरे पास क्या आ गया, 1 1 1 0 14 आ गया।
लास्ट सेट बिट।
अब देखोगे कि 14 की अगर लास्ट बिट रिमूव कर दे तो मेरे को 13 रेंज में आएगा, क्योंकि 14 क्या स्टोर कर रहा है, 14 स्टोर कर रहा है 13 से 14 का सम, राइट। अब इसकी लास्ट बिट निकालो, इसकी लास्ट बिट क्या है, ये। अब ऐड कर देंगे, हमें क्या मिला, ये मिल गया। ये क्या है, 16 है। अब 16 किसका सम स्टोर करेगा, 16 स्टोर करेगा, इसकी लास्ट बिट हटा दो, तो इसकी लास्ट बिट हटाने के बाद क्या मिलेगा, 0, तो 0 + 1 1, तो 1 to 16 का सम स्टोर करेगा ये, है ना, इस रेंज का सम स्टोर करेगा 16th इंडेक्स। तो 16 की रेंज में भी 13 आ रहा है, तो 16 में भी 13 ऐड करना पड़ेगा। अब इसमें 1 और, अब इसका भी लास्ट बिट निकाल लो, लास्ट सेट बिट इसका क्या है, यही है, तो इसमें यही ऐड करना पड़ेगा दोबारा। तो ये क्या आ जाएगा, 32 क्या स्टोर करेगा, 1 to 32 का सम, क्योंकि इसकी लास्ट बिट निकालेंगे तो 0 आ जाएगा, 0 + 1 to 32 का सम स्टोर करेगा। तो ऐसे ही ये बढ़ता जाएगा। तो आप देखोगे कि 16 से 32 के बीच में जितने भी नंबर हैं वो इस नंबर से बड़े होंगे, मतलब उनमें यहाँ कहीं पे 1 होगा, राइट। तो अगर उनकी कोई भी लास्ट बिट हटा दें तो वो नंबर 16 से बड़ा ही होगा हमेशा, तो कभी भी 13 उनमें आ ही नहीं सकता है। तो 16 के बाद जो नेक्स्ट नंबर है वो हमेशा 32 ही होगा। तो हमें बस लास्ट सेट बिट दोबारा ऐड करनी है। पहले हमने क्या किया था, लास्ट बिट माइनस करी थी, इसमें हमने लास्ट बिट ऐड करनी है ताकि हम सारे वो नंबर्स फाइंड कर सकें जिनकी लास्ट बिट रिमूव करने के बाद एक ऐसा नंबर आए जो 13 को इंक्लूड कर रहा है। तो इस चीज को हमें कोड में कन्वर्ट करना है। तो वो कैसे करेंगे, एक ऐसा फंक्शन लिखना है अपडेट जिसमें ith इंडेक्स में हम x ऐड कर सकें, राइट। तो वो कैसे लिखेंगे, तो हमें यही चीज करनी है, i की लास्ट बिट फाइंड करेंगे, i में उसकी लास्ट बिट ऐड कर देंगे और उस नंबर में हम अपना x ऐड कर देंगे, बिकॉज उस नंबर की रेंज में हमारा i आ रहा है। तो हम क्या करेंगे, और ये हमारा अपडेट फंक्शन हो गया। तो हमने क्या किया, i की लास्ट बिट निकाली i एंड -i से, उसको i में ऐड कर दिया हर बार, और bit ऑफ i में x ऐड कर दिया। तो इससे हो क्या रहा है कि पहले 13 था i, राइट, तो 13 में हमने x ऐड कर दिया, bit ऑफ 13 एरे को हमने किसी वैल्यू से ऐड करना था, तो हमने bit ऑफ i में क्या कर दिया, x ऐड कर दिया, तो bit ऑफ 13 में x ऐड कर दिया। अब और कौन से नंबर्स हैं जिनमें 13 इंक्लूडेड होगा, उससे वो कैसे फाइंड करेंगे, लास्ट बिट फाइंड करी 13 की,
₹100 received on PhonePe.
उसको 13 में ऐड किया, हमें क्या मिला 14, वो हमने यहाँ पे किया। अब 14 में भी हम x ऐड कर देंगे, तो हमने bit ऑफ i में दोबारा x ऐड कर दिया, फिर 14 की लास्ट बिट निकाली, उसमें उसकी लास्ट बिट ऐड करी और उस नंबर में भी x ऐड कर दिया। कब तक करेंगे, जब तक ये n से छोटा है। n क्या है, हमारा a का साइज, मतलब जो गिवन एरे है उसका साइज है, ये ग्लोबल वेरिएबल है और bit भी एक ग्लोबल वेरिएबल मान लो। तो ये हमारा एक अपडेट फंक्शन हो गया। तो हमने दो टाइप के फंक्शन देखे। पहला फंक्शन क्या है, सम इंट i। ये फंक्शन क्या है, ये हमें ith इंडेक्स तक का सम देता है। और दूसरा फंक्शन हमने देखा अपडेट इंट i इंट x। ये क्या करेगा,
क्वेश्चन आएगा क्या यार,
subtracting 0, we
ith इंडेक्स में x वैल्यू को ऐड करेगा। ये ध्यान रखने वाली चीज है कि ये ith इंडेक्स में x वैल्यू को ऐड करता है, उसको रिप्लेस नहीं करता x से। तो बीआईटी में एक और देखने वाली चीज है कि ये जो जीरो है ये हम कभी नहीं मानते हैं। तो बीआईटी में हमेशा जो एरे की इंडेक्सिंग है, इट्स बेटर कि तुम यार वन बेस्ड इंडेक्सिंग यूज करो क्योंकि अगर तुम अपडेट फंक्शन इसमें जीरो दे दोगे तो ये जो लूप है i प्लस इक्वल टू आई एंड माइनस आई, ये जीरो हो जाएगा, ये जीरो प्लस जीरो जीरो हो जाएगा, तो ये इनफाइनाइट लूप चल जाएगा। तो बीआईटी में कभी भी जीरो इंडेक्स को यूज नहीं करते हम। बीआईटी में हमेशा तुम्हें वन बेस्ड इंडेक्सिंग ही यूज करनी है। एरे में तुम वन जीरो बेस्ड यूज कर सकते हो, बट बीआईटी हमेशा वन बेस्ड ही यूज करना है। यार ये थी बीआईटी के दो फंक्शंस की डेफिनेशन। तो बीआईटी एक बहुत ही सिंपल टॉपिक है एंड आपने देखा है कि यार ये देखो ये कोड भी 5-4 लाइनों का ही है और इसका सम वाला वर्जन भी 4-5 लाइनों का है। तो ऐसे क्वेश्चंस करने के लिए सेगमेंटरी में आपको बहुत लंबा कोड लिखना पड़ता है। तो बीआईटी के अगर आप 2-3 क्वेश्चन प्रैक्टिस कर लो तो आपको बहुत ईजी हो जाएगा ये सब क्वेश्चंस को करना। तो आई होप यार ये वीडियो आपको
इतना ही है बे कोड। व्हाट अपडेट I x I is less than m, I plus equal to I and minus I, bit of I. Okay, binary index tree, sum of I minus equal to, okay, you are unsetting the last mode set bit and you are updating for each, you are going back, you are coming front, okay, adding.
अच्छा लगा और हेल्पफुल लगा।
Your American dream, now a reality. With a 1-year STEM master's, graduate with a 3-year US work visa and a high-paying job at the Big Four. Over 20,000 programs at 1,000 top American universities. Scholarships worth $50,000.
हेलो दोस्तों, तो यार लास्ट वीडियो में हमने डिस्कस किया कि यार बाइनरी इंडेक्स ट्रीज क्या होते हैं, उनकी सम और अपडेट क्वेरीज कैसे करते हैं और उनको इम्प्लीमेंट कैसे करते हैं। इस वीडियो में हम देखेंगे कि यार बाइनरी इंडेक्स ट्रीज के क्वेश्चंस कैसे होते हैं और उनको कैसे करना है। तो अगर आपने मेरा लास्ट वीडियो नहीं देखा है तो पहले आप उसको जाके देखो, मैं यहाँ पे आई बटन में उसका लिंक छोड़ दूंगा। तो अब हम देखते हैं कि इसके क्वेश्चंस बाइनरी इंडेक्स ट्रीज के कैसे कैसे होते हैं और कैसे करने हैं। तो यार पहला जो क्वेश्चन डिस्कस करेंगे वो है, हमें एक एरे गिवन है n साइज का, n क्या है 10⁵ से छोटा। फिर हमें गिवन है क्यूब क्वेरीज, क्वेरीज भी 10⁵ है और क्वेरीज दो टाइप की है। पहली टाइप की क्वेरी में हमें i और x गिवन है, हमें एरे के ith इंडेक्स को x से रिप्लेस करना है। दूसरी टाइप की क्वेरी है l और r गिवन है, हमें एरे में l to r का सम निकालना है।
क्या क्वेश्चन है ये? टोटल query request. Convict tree. Bit of n const n equal to e5 plus 10. Whoa, there is a question, dude. Binary index tree से होगा ये question.
Accomplish.
तो इसको क्या करेंगे? तो हमने जब बाइनरी इंडेक्स ट्रीज लास्ट वीडियो में पढ़ा था तो हमने दो टाइप के फंक्शंस देखे थे. सबसे पहला फंक्शन था सम ऑफ आई. ये फंक्शन क्या करता है? मेरे को 1 से आई तक का सम देता है, राइट. दूसरा फंक्शन था अपडेट आई कॉमा एक्स. ये क्या करता है? ith इंडेक्स को x से ऐड कर देता है, रिप्लेस नहीं करता है, ऐड करता है. तो सबसे पहले इस क्वेश्चन को सॉल्व करने के लिए हम क्या करेंगे? हमें पहले बीआईटी एरे कंस्ट्रक्ट करना पड़ेगा. तो बीआईटी की इनिशियल सारी वैल्यूज 0 होती है. तो हम सबसे पहले क्या करेंगे? इस फॉर लूप में हमने क्या करा? हर एक ith इंडेक्स के लिए a ऑफ i बीआईटी में डाल दिया. तो इससे हमारा बीआईटी कंस्ट्रक्ट हो जाएगा, राइट. और आप देखोगे यहाँ पे 1 से n तक का लूप चलाया है. तो मैंने जो एरे a है उसको 1 बेस्ड माना है. तो मैंने लास्ट वीडियो में डिस्कस किया था कि इसको बीआईटी में हम हमेशा एरेस को 1 बेस्ड ही लेना है. हम कभी भी अपडेट ऑफ 0, x कॉल नहीं कर सकते. तो इसके बाद अब ये हमारा बीआईटी एरे कंस्ट्रक्ट हो गया. तो अब हमें क्या करना है? हर एक क्वेरी को हैंडल करना है. तो क्वेरीज को कैसे हैंडल करेंगे? अगर मेरी क्वेरी है टाइप 1 की, मतलब i और x होगा, ठीक है. तो उसमें मैं क्या करूंगा? अपडेट अब यहां पे कौन सी वैल्यू आएगी? देखो जो अपडेट
यार क्या है इसकी? मैं स्क्रीन ऑफ क्यों हो रही है?
i कॉमा x है वो क्या करता है कि ith इंडेक्स में x को ऐड करता है. बट जो हमें टाइप 1 की क्वेरी करनी है उसमें क्या करना है? हमें ith इंडेक्स को x से रिप्लेस करना है. तो लेट से मेरा अगर ith इंडेक्स पे पहले 4 था, अब मेरे को क्वेरी आई i कॉमा 6. अब मेरे को क्या करना है कि ith इंडेक्स पे 6 करना है, राइट. तो मैं अगर यहाँ पे i कॉमा 6 कर दूंगा तो मेरा ith इंडेक्स पे 10 हो जाएगा, क्योंकि ये ith इंडेक्स पे x को ऐड करता है. तो मेरे को ith इंडेक्स पे यहाँ पे क्या अपडेट करना है? 6 माइनस 4. तो बेसिकली यहाँ पे मैं अपडेट क्या करूंगा? x माइनस a ऑफ i. तो इससे क्या होगा? जो डिफरेंस है वो अपडेट में जाएगा. तो उतने से वैल्यू हमारी ऐड हो जाएगी, क्योंकि हमें वहां पे वैल्यू को रिप्लेस करना है. अगर टाइप 1 क्वेरी यहाँ पे होती कि ith इंडेक्स में x ऐड करना है तो ये ai वाली टर्म नहीं आती. बट हमें एक ith इंडेक्स को x से रिप्लेस करना है, इसलिए ये x माइनस ai कर रहे हैं यहाँ पे. और यहाँ पे क्या करेंगे? ai इज इक्वल टू x. ठीक है, ये हो गया टाइप 1 की क्वेरी. इफ अगर टाइप 2 की क्वेरी है, टाइप 2 की क्वेरी में क्या करेंगे? सीधा सी आउट सम हमें क्या निकालना है? L2R का. तो सम ऑफ R माइनस सम ऑफ L माइनस 1. ये हो गई मेरी टाइप 2 की क्वेरी. तो ये एक सिंपल सा क्वेश्चन था बाइनरी इंडेक्स ट्रीज पे. अब हम बढ़ते हैं नेक्स्ट क्वेश्चन के ऊपर. तो दूसरा क्वेश्चन है यार, मेरे को एरे का इन्वर्जन काउंट फाइंड करना है और जो एरे का साइज है वो 10 to the power 5 से छोटा है. तो पहले तो डिस्कस करते हैं इन्वर्जन काउंट क्या होता है। तो इन्वर्जन काउंट होता है कि यार ऐसे कितने एलिमेंट्स हैं सच दैट ए आई इज ग्रेटर देन ए जे एंड आई जो है लेस देन जे है। तो सबसे पहले समझते हैं कि इसका मतलब क्या है। लेट सपोज मेरे पास
क्या बकवास है यार ये। So you have update, you have sum range and you have init. This is literally the Fenwick tree question, bro. Okay. Self dot Fenwick tree is what? 0 into what is the length? Length of the Fenwick tree is 3 into 10 to the power 4 here. Okay. N will be equal to len of nums into n plus 1 का Fenwick tree बनाएगा मैं. Okay. 4I in range n, we need to simply update the value. Whatever there in the Fenwick tree minus it will store some sum and all. I need to update index I plus 1 with nums of I. अपडेट व्हाट टू डू फंक्शन में क्या लिखा था भाई अपडेट की सम शुड बी इजी राइट लेफ्ट एंड राइट get sum of right self to get the sum of get sum of comma I till ith index I have to get some while I want to go to 0 I is greater than 0 one particular just add self dot fw tree of I plus equal to sum plus equal to self dot of w tree of I add and then move I minus equal to I and minus I and minus I will give me the last set bit and we are removing the last set bit, unsetting the last set bit. Return sum update you wanna add some value. Okay, and initially we have all values are 0 in the Fenwick tree. Okay, I want to add one value 5 to to the second index. If I want to add one value to the second index, 5. Okay, current index minus okay, it becomes 5. I want to change the value to 3. Then what do you want to add? You should add minus 2, right? A of I minus the number. If you take the current element 0 minus, simply update it with nums of I. Nums of I keep adding to that range. Update कैसे काम करेगा? At index I, index comma val. Okay, index we have val index okay less than self.n. Okay, index, add the value to each of index to val index plus equal to, you have to add the lastmost set bit. How do you get? You do to do and minus index. Okay, this guy returns nothing. Okay. Null 1 6, null 9, null 8. Oh, okay. Also, okay, you should not add val. Val will be equal to self dot. You should always maintain nums. What? Nums equal to nums of index minus 1. Okay. I've got index minus 1, nums minus 1, index minus 1. Minus the current value. No. If you want to update it to 7, right? Value minus. Okay. Wait a second. But if I have 5 and I want to make this 3. I'll make this 3. 5 minus 3 is what you will add. No. Adding is what I'm doing, right? Whatever number you have minus val. इसको कैसे डिबग करें बे? Okay, left and right are what? Okay, in update you're sending index +1. Okay, you should send correctly यार, क्या कर रहे हो आके? They will call update, bro. Okay. Wait a second, get some of the ith index. Increase the index by 1. Yes. I increase the index by 1 and then I give self.fw tree of I minus equal to I and क्या है भाई? If type 1 update ith index x minus a of it. What? कुछ समझ नहीं आ रहा भाई, क्या किया इसने साला? इधर तो i plus 1 ही होगा. Oh, you don't need to worry about this. I0, it will never enter the loop.
एक एरे है, ये जो एरे ए है उसको 1 बेस्ड माना है. तो मैंने लास्ट वीडियो को ये एल और आर गिवन है, हमें एरे में एल टू आर का सम निकालना है. तो इसको क्या करेंगे? तो हमने जब बाइनरी इंडेक्स ट्रीज लास्ट वीडियो में पढ़ा था तो हमने 2 टाइप के फंक्शंस देखे थे. सबसे पहला फंक्शन था सम ऑफ आई. ये फंक्शन क्या करता है? मेरे को 1 से आई तक का सम देता है, राइट. दूसरा फंक्शन था अपडेट आई कॉमा एक्स. ये क्या करता है? ith इंडेक्स को x से ऐड कर देता है, रिप्लेस नहीं करता है, ऐड करता है. तो सबसे पहले इस क्वेश्चन को सॉल्व करने के लिए
update I comma nums of I. I will update with what? nums में whatever है उसमें -val, which is wrong, right? You should update with val minus whatever. If I have 5 already and if I want to make it 3, right, what do you add? You need to add -2, 3 minus 5. Okay, this is correct. Update I is less than n, I is less than self return. Bit of I plus equal to x. Index plus equal to index into minus I. क्या गलत है यार इसमें? इतना सा छोटा सा प्रॉब्लम है. n you are setting to n plus 1. Okay, that is the limit. No, this n is okay. And we are treating the ith index with nums of I. Okay, perfect. Ith index with nums of I. Perfect. What is the mistake here? increasing I. Okay, get sum of I and j, right minus I minus 1, perfect. Now update. In the update, what is he doing, man? Okay, he has init function also. Diff is getting val minus. Oh, here he is not doing index. Okay, not. So fine, anyway, 0 ही है ना यार. So this is my problem. I don't know. Okay, this is an infinite loop now. What? Init I comma diff. In init he increases the thing by 1 and value is diff val minus thumbs of I. Same thing I did. Okay, same thing I did. Index is less than or equal to n. N is not. Okay, let's make it equal to self-return. ये काम क्यों नहीं कर रहा यार? What is wrong with this man? Get the diff, that is the value, which is value minus whatever is there in the current one. Self.fw tree of. Hey, yeah, I'm doing everything correctly. Where is the bug? I can't find the bug, man. Bug किधर है? This is the bug. क्या बकवास है यार? This guy doesn't know anything. Oh. Left minus 1, you can't do like that too. Even if I return minus 1, right, get sum of minus 1, what will happen? Minus 0, index will become 1, right? क्या गलत कर रहा है यार? So let's add this check and see. same issue is community. Get some में प्रॉब्लम है ना, अपडेट में प्रॉब्लम है, किस में प्रॉब्लम है? सेल्फ तो what is the bug, man? भाई साहब, सेगमेंट ट्री की ऐसी कितना ऐसी है भाई, बकवास यूजलेस सेगमेंट ट्री. This guy has code for everything, bro. Is this the issue? Nope. What? The correct expression should be index plus equal to index on. This guy is an idiot or what, man? Let's just, I mean, if I print the FW tree, what the hell will I understand? क्या पता चलेगा अपने को? Get some. क्या ही हो रहा है? Bro, I'm not really sorry, man. Wow, bro, I can't find the bug. Let's print the... After updating, let's printing both. Whoops. ये क्या किए हुए कारनामा? ये क्या है बे? What? It's a one-day around, right? ये क्या हो रहा है बे? इतना सारा update is called only once. इतना सारा क्या प्रिंट कर रहा है बे? चार बार अपडेट कॉल हो जा रहा है. Who is calling update 4 times, man? 4 times y, man. Oh. Okay. Okay, I'm an idiot. Init, right? Add value. 01456 से init होना चाहिए भाई. तुम्हारा update function में प्रॉब्लम है. What the? Okay, why should you separate add and update? Oh, oof, dude. Ah. Still it doesn't work. You want to add value and then replace the index. Construct is different, huh? सही तो है यार, फिर क्या? Oh, okay. I think I understand what is happening. नहीं FWT को क्यों अपडेट कर रहा है पागल इंसान. Yeah, I don't know what to do, man. I'm fucking for this question. Update, what is he doing? He's taking the diff and he is sending the diff to the add value and he's updating nums of index. I think separate out add value and update here. Def add val self comma index comma val value you take will be equal to val minus self of nums dot index. Shouldn't do all this here. इधर सिर्फ ऐड कर देना है वैल्यू बस. Index you increase by 1, while index is less than self dot n, less than or equal to subset of WT index plus equal to val. Okay, add val हो गया. Update. In update what do you do? Add val of self dot add value of index comma val minus self dot nums of index. Diff is equal to val minus self dot nums of index. We are sending add val diff and self dot nums of index is val. Yo, what is wrong now, bro? Oh, now I have to construct the tree properly. Construct the tree properly. The difference between add values, add and update. You add the difference and update the current value. Here you just adding the values. You're not updating the original nums. We have init nums. Okay, how do you do it in 2D matrix?
सडनली आ गया गाने में.
लाइट ऑन करो यार. Delta you get nums of row column you update. Okay, you just make a Fenwick tree of 2mn. I guess. Tree is equal to unit of n plus 1, n plus 1. Okay, the tree is also of size 2. n plus 1, n plus 1. Equal to delta.
डोर से मच्छर आ रहा है.
ये चलाओ ना भाई, लाइट चलाना. int I is equal to row plus 1, I is less than m, I plus row is equal to row plus 1, column plus 1. Why? Okay, because if Fenwick tree में plus 1 करना पड़ता है, that's why. Tree of I plus 1, j plus 1, they are adding the delta. Tree of I plus 1, j plus 1 plus equal to delta. Same thing is doing some region of row 1. M or n is equal to 0, you can return 0. Why? What is m and n? Okay, I minus and gt I. Okay, BAT does not include left bound. क्या है यार? m plus 1 is the tree. Nums you have. Update. In the update function, what do? It is m plus 1, n plus 1, right? Okay, that's why. Okay, delta you calculate. Row column. Nums of row column is equal to val I is equal to row plus 1 is then equal to m I plus equal to update me, you keep increasing. In the tree you add the delta. Okay, nums of row column is setting the value here, and that you add the delta. Okay, some region row two call 2 plus 1. Okay, something is doing here. Some I is equal to I row, j is equal to column. Okay, init means I need to initialize a b of f and victory of length what m and n will be equal to no, n will be equal to n, so 0. Okay, then you have dot different vector will be equal to 0 into n plus 1 for underscoring range fan vector बना दिया. Now what? Now we have to iterate through the matrix. M for j and range n self dot update okay, update I row comma column with value what column is. Okay, also you need to save the matrix also. Subdot matrix is matrix of I and j is what we're gonna update. Okay, how do you get this update? So let me update row increase by 1, but before increasing the row and column you need to get delta will be equal to the current matrix of row and column minus val minus current row and column. Okay, and then you update self dot matrix of row column to the new val for I in range from I think instead of doing this from row plus 1 we start, we need to go till where self to 10 self dot add करो इधर column plus 1 to self dot n plus 1. Okay, simply do dot fw tree of okay. Also each step what do I need to do? Step value, right? Step value is what you add. You have to add here I plus I and minus I and minus I. I plus equal to I and minus I. ij plus equal to delta अपडेट हो गया and from row plus 1 to m plus 1 each step I plus equal to I and minus I. Yep. And here also j and minus j. Now what do I need to do? Update हो गया sum region. Okay. Def get sum of self comma index. Right. For index I need to get sum. For I in range index plus 1 till minus 1 till 0 till 0 minus I and minus I. Okay, I and range index plus 1 to 0 minus I and minus I. Get sum using the sum. Sum is equal to 0. Okay, sum plus equal to subproduct regulatory of I. Sum साला क्या कॉम्प्लेक्स है यार. Oh, it's a 2D matrix, man. For chain range column plus 1 to 0 I go minus j and minus j. Last set bit you're removing each time. ij return some region of row column row to column 2 में क्या होगा. return self dot update ने get sum. okay, पहले क्या क्या समझे भाई. row to column 2. yep. row to row to column 2 what? I don't know how to do this, bro. row 2 column 2 get sum of this one column 1 minus 1 comma प्लस माइनस क्या था यार रूट 2 कॉलम 1 minus 1 रूट 2 column 1 minus 1 yep root 2 minus 1 minus dot get sum of row 1 minus 1 column 2 unbound variable what is unbound here dude? Unbound local error I cannot access local variable when I is not associated with the value what cannot exercise when I is not associated with the value. What does that mean, bro? Oh.
चुप रहना
What? क्या बेकार सॉल्यूशन दिया भाई इसने तो when you're trying to iterate over the range using it. What? What? He's not using a for loop, bro. He's using a while loop. I guess we need to use a while loop then. J plus equal to J and minus J I plus equal to I and minus I. It's nine, I equal to I will be equal to row plus 1, J is equal to column plus 1. J minus equal to the bits. भाई इसका बग को कैसे ढूंढूं यार मैं IJ matrix of IJ. कितना कम कोड है यार, स्टिल यू नॉट एबल टू गेट द आंसर. -1 row 2 equal to row 1 column 1. Row 2 column 1 minus 1 column 2 यार wait a second. What am I doing? सही किया था यार. ये कैसे है यार तब. Oh yeah, I remember. Okay. Row 1 minus 1 column minus 1 row 1 minus 1 column 2 row 2 column minus 1 row 2 column minus 1 equal minus है plus है perfect some corner res will be 0, I will be equal to row plus 1. Column is not initializing. For each time you have to initialize column 2. क्या गड़बड़ है यार? What? Exact same code यार. What is the problem now? बियॉन्ड कंपेयर करें क्या? Oh, he's creating a new matrix. Oh, ho. So that's why you can call update. I can call update, yeah. Longest substance, Leetcode 340. s and a k and an integer k to return the length of the longest substring that contains at most k distinct characters. Okay, what? At most k distinct characters. Okay.
अबे यार मुझे कौन मारा बे?
At most k distinct characters. Okay, there shouldn't be more than k distinct characters. Okay. Sliding window. Okay, do understand at most k distinct characters. There shouldn't be more than k distinct characters. Okay. Okay, I have a sliding window. But what will be the length of sliding window can't work. How do I get rid of the scale, man? Okay. At most k characters. K unique characters. Let's take this one. This has 2, length 2. This has 3. Only 2 characters. It has length 3. This has 3. It can't work. This only has 3. This also has only 3. So 3 is the length. Answer. Okay. At most k characters. Most k unique characters need to be there. At least k okay. How many? At least k repeating characters. 395. At least k repeating characters. This is at most k unique characters. Okay, how did you do it there, dude? Divide and conquer problem. में क्या क्या सोल्यूशन था यार? Least k divide and conquer, same thing. At least k repeating characters. He's forming n square substrings and he's checking. Count map array to store the frequency is valid method is used count map to check whether every character in the substring has at least k frequency. Okay, n square, so I can do this in n square easily. Just form all the substrings and just check all the in the current substring how many unique characters are there. Okay, n square. We need to generate substrings, right? We can generate all substrings in n square, and each substring you need to check if there is more than k distinct characters. You can end the iteration there, but still there will be n square only. Let's implement this in 5 minutes. In range len of s for I in range n, for j in range of okay. Current string is just this SFI, it's nothing, and also current string is nothing, also curset is set, just add curset, add करो but why do you need to do this, man? Just get the length of current string in j minus I, right? Yeah. This is useless. That string dot curset dot add s of j. If curset len of current set equal to k, at most k distinct characters. Answer equal to marks of the current answer and j minus I, this one. Else you can break the inner loop. You need to check another substring. n square accept क्यों नहीं होता है यार? What? ये क्या है? At most one character should have. Okay, I is going from 0 to should go from 0 till n, and your j you start at I and then you go till n. Okay. अब क्या TLE? Dude, how do you do it in a window? I think it's the exact same question though. Okay, what is n square has for complexity? If I implement the exact same solution, right? With at most k tha, उधर at least k tha. Okay. So what will I do? I make a sliding window. So I get all the unique characters, a number of unique characters in a string. I get max unique. Okay, it needs to be a string. It needs to be a substring of some size with, okay, you get all the unique characters. Okay, with at most k unique characters they want, at most k. So answer can be a substring, the longest substring with 1 unique character, longest substring with 2 unique characters, the longest substring with 3 unique characters, longest substring with 4 unique characters. Till k you have to run, at most k. whatever is the answer is the answer. Okay, this is complexity of k into n. Okay, let's implement this in 10 minutes fastly, and you can implement this one without a set also. This one will implement without a set. So I have most k characters, at most k characters, right? How do you do it? At most k distinct characters. So you get the max unique characters, which is set, which is len of set of s. If maximum unique characters at most k, then it's okay. Okay, for current unique in range, it needs to be at most k. It can be max unique or k, current unique. Also, it will start with 1. Okay, then current unique you have set. Start is 0, start from end is 0, 0, window. At most k distinct characters. What was the question? At least k repeating, that's why the frequency mattered. Here distinct characters also you need to calculate using frequency only. Let's see. Car fric is a 0 into 26 array. Current unique window unique is the current window's unique characters, and is less than n. Let's see, we have another. I will write a nested function or I can write a input function and get memory of, we take a character and it will return integer. Return quality of c minus quality of a character. Window unique is 0 while end is less than n. Okay, while end is less than n, you need to do what? Current character is n. Okay, when do you increase the size of the window? When we increase the size of the window. Okay, let's say in the current window, unique characters. Okay, wait, why do you need to check every single window like this, dude? Checking at most k distinct only substring. At most k distinct characters, If the current window has k characters, right, then you have to k unique characters, and you have to increase start. Let's see, less than or less than ही होगा यार, it won't be. K current unique, if window unique start is 0, end is 0. No, I add end 0, end is 0. if okay, you can't get like this, dude. You have to try out every single one, dude. I guess. So single sliding window you need, that's all. Just you jump to number within the sliding window. Just a single sliding window will solve it. If window unique, which is 0 right now, if window unique is less than the k, then you can expand the window. Okay. Expand the window. Expand the window में you simply need to set the frequency. Check if the frequency becomes 1 after update the frequency of the current character plus, so each frequency will become 1, and then is frequency become 1, yes, w unique increase by 1. So this is in my thing, and then I move and I already increased here, and I increase here else. Okay, also where do I check? In the else, if I'll check if window unique is equal to k. Save the answer equal to max of, I think I can directly code this one, I don't even need to. But why does it work? K distinct characters, so not at least k repeating characters, at least k repeating characters. At least k repeating characters. So what? Different number of unique characters. Oh. Okay, I made n1. If w unique is equal to k, then I update answer will be max of answer comma n minus start. उसके बाद you need to increase start, so frequency of start you make it minus equal to 1. If frequency became 0, then you can decrease w unique minus equal to 1. इतना ही करना है यार. Why will this work not? पंखा रहने दो यार,
मुझे चाहिए यार।
ऊपर का चलाओ।
ऊपर का क्यों चाहिए? बिल आएगा।
Max unique ammo we don't need. Start and 00, character frequency 0, window 0. Is less than n. Max is less than. Okay. You can add the kth character to the window. How do you add the kth character to the window? You will end the character to the window. Increase by 1 frequency of R&D plus equal to 1 and increase by 1, and then we just move the sky. Increase the window unique to 1, increase the frequency, increase the window unique, and then what do? Simply increase it. Else if is equal to k max k. Answer 0 the max of answer comma and minus start. Start. Decrease it by 1. Index became 0 means that my window unique needs to reduce by 1. Start is equal to 1. Okay. A is 1, k is 1, answer is equal to 0, while n is less than n. If window unique is less than k, that is less. Oh, the string ends. Make it equal to n. हाँ यार, इधर ही कर दो यार. 3 भी नहीं आ रहा, क्या बकवास है यार ये। EC it will make. Reduce the window to C C E D E C C E D. On the substance with utmost key distinct characters. Oh. At most it should be key distinct characters. ECE 3. Character frequency. Start is 0, end is 0. Okay, window unique is 0. End is less than n, yes. This window unique less than k. Yes, character index s of end. So update the character frequency. Each frequency or make one. Make window unique will become 1. Okay, and you need to increase. Is window unique equal to k? Window unique is 1. No. I need to only reduce when it become window unique goes above k. Wait a second, what? Even if it needs to go above k only when at the most k distinct characters. So window unique if window unique goes past the thing, only then we care. Okay. If unique greater than k, else simply add another character. At most k can be less than or k equal to. इधर क्या आउट ऑफ इंडेक्स हो रहा है यार? इंग्लिश कैरेक्टर से ज़्यादा है. क्या बकवास है. Default dict. One 32 test cases passed. Design tic-tac-toe. Assume the following rules are for the tic-tac-toe game on an n-cross-n board between two players. Okay. A move is guaranteed to be valid and is placed on an empty block. Once a winning condition is reached, no more moves are allowed. A player who succeeds in placing n of their mask in a horizontal, vertical or diagonal wins the game. Okay. Tic-tac-toe कैसे खेलते हैं? Initializes the object of size with n size board move id plays at cell. The move is guaranteed to be valid move and two players alternate in make moving. Turn 0 if there is no winner after the move. Turn 1 if player 1 is the winner after move or player 2 is winner after the move. Tic-tac-toe, the board is of size 3, okay. 3x3, it is a board of 3 cross 3. Player 1 makes a move at 0. At 0, 0, player 1 is making move x, okay. At 0, 2, 0, 0, 0, 2, 0, 2. Player 2 has made one move, x, o, x. O X. You don't even need to keep track of anything. And what is the max board size? 100. Okay. In horizontal, vertical, or diagonal rows wins the game. Okay, placing the things is not an issue. How do you check in O like fastly. n square में करोगे तो it won't pass. n square per move. Huh. Could you do better than n square per move? How do you check if row 1, row 2, column 2, column, and then 2 diagonals you have to check, that's all. Okay. How do you do better than n square, man? Player 2.
Dragon of the Hunter, yes.
And player 1. And player 2. And player 1. How do you know when the game ends? No, X, it is X's turn. X wins. What? When does a game become draw, man? When does a game become a draw? Board something like this. The board becomes full, I guess. When it becomes a draw, I don't know. When the board becomes full without winning. Okay. It will always be a valid move. Board becomes full, it is draw, and then for each move I fill and then I check the whole board again and again. I check the whole board, all columns, all rows. I check the rows if they are the same. I check the columns if they are the same. Also I check the diagonals if they are the same. Each time player makes a move. How do you do it in O(n), man? If I have a matrix, you have XX here already, dude. कैसे करे यार? कैसे करे भाई? Oof, one solution. No way, bro. Hint is there. Oh. Extra space such that move operation can be done of one. Could you trade extra space? Okay. What? When you move right, three things can happen. When nothing happens, the game ends, somebody wins, or it is a draw. Extra space says that move operation can be done of one. Oh. Okay. You just need to calculate, dude. Okay, I have a row sum array and I have a column sum array. Whenever the player 1 makes move at a row, I increase the row sum of that particular row and the column and the diagonal also. No. Okay. X has made a move at 0 0 and make this one 0 and make this one 0. No, this 0th row, 0th column. First row, 0th column. First 0th row. When X makes a move here, when X makes a move here, we simply increase the row. Make it 2. Okay. And column 1. Column 1 पे 1 sticky बनेगा इसका. We make it 1. Then let's say X makes here. Okay. That's interesting. X. Okay. Now player 2 0 1 2 0 1 2. If player 2 makes a move here, obviously player 2 is blocking this guy. So I will make this guy, I'll reduce by 1. Whenever player 2 makes, whatever row he makes, I reduce by 1. Whatever column he makes, I reduce by 1. I reduce by 1. Wait a second, what was it here originally? Column 0 पे 1 हुआ और column 1 पे 1 हुआ. So, wait a second, whoa, this won't change. Row is 0, column is 2. So 2 sum is minus 1. At any given point, when I increase the row or sum, if it becomes equal to minus row of row num, player 2 wins, plus row num player 1 wins. Okay, player 2 gives 0, then player 1 tries to put an X here, the game is over, bro. This game is screwed, bro. What? This is the wrong game. Okay, let's say the player 2 is dumb. He doesn't. Player 1 is only dumb. Puts here. Okay. Player 1 is second row, second column, second row, second column becomes 0. And now player 0 makes a move here. 1 1 first row, player 0, so 1 I have to decrease this, make it 0. Oh, at 1 row he made a move.
कितना मिस होगा जरा बताना
-1. अच्छा है
पता रे
at 1 make this guy 0. First column player 1 had made a move, that's why it's 0. Okay, now X guy will make a move here. 2. Okay, I'm not even tracking diagonals yet. I don't know how to track diagonals. How do you track diagonals, man? Makes a move in first row, 0th column. But how do you track the diagonals? Oh, diagonal sum he's calculating. What? He's created the grid int move. Check vertically win. And I is equal to 0, I is less than grid length I plus plus. If grid if I code not equal to player return false. Horizontally win. Diagonally win. Boolean top left to bottom right equal to true, top right to bottom left equal to true. Okay, in the move में rows of row player 1 plus 1 player 2 minus 1 perfect columns of call. But how do you check diagonals, man? If row equal to column. Oh, okay. A row and column is same for the diagonals, dude. Top left to bottom right plus. Oh, okay, makes sense. If row plus column equal to row length minus 1. What? If row top right to bottom left, top right to bottom